Hello everyone, thank you to all of you for being here and welcome to COMSOL Multiphysics training course. My name is Mustafa and I'm here to present a heat transfer and fluid flow using COMSOL Multiphysics. For this purpose, I will follow this content starting the problem definition. For example, geometry, we will define geometry, materials, and also boundary condition. And then we implement all these properties into the COMSOL multiphysics area. And after generating mesh, we will get the result. And eventually, in this presentation, we are going to analysis, we are going to study parametric analysis of velocity inlet and heat flux in boundary condition. In this slide, you can see the geometry of this project that consists of fluid flow of water inside a canal with this velocity inlet and temperature inlet that exposed to the heat flux here. So the main goal is that to calculate the temperature and velocity fields inside this geometry and also evaluate the variation of heat flux and velocity inlet on these sort of parameters. Okay, for this purpose, let me go to the main COMSOL software space to start the simulation. When you open the COMSOL multiphysics software, this is the first page you can see. After choosing model wizard, you have to define the dimension of your study due to 2D heat transfer and fluid flow. In our project we choose this one, and then here we have to choose all physics we want to study in our project. For this purpose, because I want to study heat transfer and fluid flow, I choose this parameter, this physics laminar flow in non-isothermal flow, and add it to the our model, and then we can start to simulate. Here, note that here we can add your physics separately. For example, you can choose single phase laminar flow and also heat transfer here, solid or fluid in your system. And it doesn't matter you choose another way or this way. Okay, next page. Here we have to define or study in terms of time. Due to the nature of our study and our goal, we choose the stationary for studying steady state. Yes. This is the main page of COMSOL software, which I have talked about a lot in previous presentation. To review, in this page we are able to generate our geometry in model builder and also define your material, and you can see all physics that you choose in previous stage here, and then couple your physics, and after generating mesh you can start your simulation, your study. For our example, at first we have to define our geometry. For this purpose, in geometry, right click and choose the rectangle, and here you can define the dimension of our rectangle. 0 and after that, we have to add our material inside the system, inside the model builder. For this purpose, right click on material and add material from library, and here you can write water here to look for your material, and also uh, here we have the material. Let's see, liquid and gas and water. Add to component. Okay, here we have all properties of or all properties of water depending on the temperature and other parameters to calculate the properties or temperature or other properties of our material after exposing the boundary condition. Okay, here in laminar flow we have to add our velocity inlet here. After choosing velocity inlet, we can write the amount of velocity here and also define in parameter, and then write the parameter here. This is the best way to write the parameter here, and then define the parameter here as a yes. So we define the velocity inlet here and then type the velocity inlet here. For this purpose, at first we have to choose the boundary which is related to the velocity inlet. Then we have to define our outlet as a pressure constant. Outlet boundary, boundary here, and then pressure 0 for pressure in outlet. Okay, now we can define the boundary condition which is related to the heat transfer. At first, we have a temperature inlet here with the amount of 300, and also heat flux here. No, heat flux here. Yes, we can define as a parameter or here 1000 kilowatt per square meter. For this boundary condition, we have to define the line which is related to our system, and then the next we have to define the outlet. For this purpose, right click on heat transfer and outlet here and choose the boundary. Yes, and then to choose the material, yes, this is the water. We consider water in all domain, and then couple our laminar flow with heat transfer, and then generate mesh. In this study, due to simplicity of our example and geometry, not need to do some activities for mesh generation. If you need, just right click on the mesh and adding different adding uh, some parameters, some action on your mesh, for example, to add cutting edge method or boundary layer, or adding different layer, or defining your the size of your mesh, you can add here. After that, we can uh, select the compute to get the result. It takes much time, and after a while we can see here the error lines of our each iteration. Yes, immediately it will be converged, and we can get the result here. We can see the velocity and pressure and temperature of our system, and also you are able here to adjust the your figure, for example, show the maximum and minimum unit, and also title and other parameters. In the next step, we are going to evaluate our system in different inlet velocity and heat flux. For this purpose, let's return to system, and at first we have to define heat flux as a parameter here, type here, and then you have to right click right click on study and choose the parametric sweep. After choosing parametric sweep, you are able to add your parameter here, for example velocity and heat flux, and define the starting point and ending, and also steps. Here you can see uh, we can write here the starting point for velocity 10 and 1 place, and also for heat flux 100 and 1000 kilowatts. Replace. If you choose the specific combination here, each of these parameter, for example, the velocity of 1 for the velocity inlet, and also the last one for heat flux, will consider for our solution. You can see here, if we select the compute, you can see the result here. Due to choosing the specific combination, the system give us three solutions for different velocity inlet and heat flux. And if we choose the all combination, different combination between the velocity inlet and heat flux will be presented here. So here you can see the velocity, and we are able to choose each of them to get the result and see the result here. This is velocity and pressure also, you can see, and also temperature. Okay, if you choose the all combination, it takes much time and you have many solutions based on your parametric sweeps. Okay, thank you for your attention. If you have a question, just send me an email to discuss more.